Hello students, this is Mr. Ezra, and before we begin our geometry course, I know you're excited to finish up Algebra 1 and finally be starting geometry, but I've got a little secret for you. You're still going to be doing algebra. I don't know if you heard me since I whispered, but you're still going to be doing algebra, and that's okay. I mean, algebra is a fundamental component of any advanced math once you get past algebra. So it doesn't ever go away. It's not like you're doing geometry now and it's just geometry and there's no more algebra. Algebra is kind of like underpinning of everything. So with that, we are going to start our discussion of geometry reviewing a little bit of algebra, and that's reviewing the solving of equations. As your Algebra 1 teacher probably worked with you on. There are many ways to solve multi-step equations, but this flowchart kind of gives you a good way that kind of usually always works unless it gets kind of crazy. You're going to start with the distributive property, which means if you have parentheses and you need to multiply into those parentheses, go ahead and do that. Combine like terms, then collect variables either to the left or the right. Undo addition or subtraction, undo multiplication or division, and then, of course, if you want to make sure you got it right, you always check your answer. And as equations get a little bit more complicated, this process isn't like set in stone. You know, sometimes you can do things in a little bit of a different order, but this is a good place for us to start as we're kind of working through some multi-step equations together and starting to think about the algebra that we're going to be using with some of our geometry course. So here are for our first two examples. In the first example, we have 26 plus 9x equals -1. I don't have anything to distribute. I don't have any like terms that I could add on either side of the equal sign. I only collect variables if they're on both sides of the equal sign. So I'm going to actually undo the addition or subtraction first, and that means this constant term over here that's by itself, I'm going to undo that positive 26 by subtracting 26 on both sides of the equal sign. I'll bring down the 9x, and then I'll bring down the equal sign and add -1 plus -26 to get -27. And then after that, we are going to divide both sides by 9, which is undoing the multiplication or division. Anytime you've got a number next to a letter, that's multiplication. 9 times x. We have to undo that multiplication by dividing so that we get the x equals -3. And when you're kind of doing this process, when you're undoing the addition and subtraction, you're getting 0. 26 minus 26 is 0, and we don't have to write the 0 because it doesn't change anything. What's happening here when we undo the multiplication or division, we're dividing 9 by 9 to get 1. And you don't write a 1 in front of an x, you just write it as x. So we are at our final answer. In the second example, we actually do have some like terms that we can add together. The 9r is a like term with the negative or minus 6r. So we're going to combine those together first by just doing exactly what you see. 9r minus 6r is 3r. Bring down the -2, bring down the equals and the 1. Now that I've combined like terms, I'm going to undo the addition or subtraction. Remember, that's the one that doesn't have a variable attached to it, so we'll add 2 on both sides to get 3r equals 3. And our last step will be to undo the multiplication or division, in this case by dividing both sides by 3 to get r equals 1. Now, we said that the last step is to check your answer, and it's something that I don't always say in the videos because I'm trying to speed things up for you, but you're just going to plug this in, and in your calculator, 26 plus 9 times -3, you'll get -1. 9 times 1 minus 2 minus 6 times 1 is going to work out to be 1. So when you check, it always works out. Example 3. This time we do have some distributive property work to do. So we're going to distribute the 2 or the -2 into the parentheses. That means you multiply everything in the parentheses by that -2 to get -8 plus 2x minus 7 equals 5. We then can combine some like terms. This time the like terms are -8 and -7. Those are the things that we can add together. So -8 minus 7 is -15 plus 2x equals 5. And if you're not good with your positives and negatives, it means you really are probably going to rely on a calculator. But get with me and I will teach you some tricks in class to work on how to make sure that your signs come out right and to remember what you're supposed to do when you multiply with integers and what you're supposed to do when you add and subtract with integers. Now that we have taken care of the adding like terms and the distribution, we're going to we don't have any variables to collect left or right, so we'll start undoing the addition or subtraction by adding 15 to both sides and bring everything down. 5 plus 15 is 20. Divide by 2. We get x equals 10. Plug 10 into that original equation. Make sure that you've done the right work. You should get 5. On example 4, we do have some distributive property work to do. That means we're going to multiply 5 times x and 5 times negative 3. We're going to combine those like terms together to get 7x minus 15 equals 13. We will add 15 to both sides. That gives us 7x equals 28. And what is 28 divided by 7? That's right, it's 4. You'll find that often the last step is to divide. I mean, sometimes you'll multiply, but usually you're going to end up dividing because you're going to have a coefficient in front of a variable and you're going to have to get rid of it by dividing. Got 2 more examples for you. In example 5, we actually do have variables on both sides of the equal sign. So there's no distributive property, there's no parentheses. We cannot combine like terms across an equal sign. It's a big kind of like a river through the middle that you can't cross unless you do an opposite operation. So what we're going to do is collect variables, which means we can't solve anything until our x's are together. So to get across this river here, across the equal sign, we're going to add 2x, since it's negative here, on both sides, and we're going to add it to the x term on the left. Now notice that it says collect variables right or left. We could have subtracted 4x to the right if we wanted to. It doesn't matter. As long as we get those x's together, we collect them together, we are going to be good. So we're going to get 6x plus 7. Bring down your equal sign. This canceled out, so equals 37. Now we can solve by adding and subtracting and then dividing. This time when you get your final answer after you divide, you get 5. You'll plug it in on the left side. 4 times 5 plus 7 is going to give you a number. Plug it in on the right side. Negative 2 times 5 plus 37 is going to give you a number. Those two numbers should be equal if 5 is the correct answer. Example 6. 2x over 3 minus 4 equals 10. Well, I can't distribute here, and I don't have like terms to combine together. I don't have any variables to collect to the left or the right. So the first thing I'm going to do is undo the addition or subtraction. And I'm going to do that by adding 4 to both sides. I get 2x over 3 equals 14. Now there are kind of different ways to do some things, and as long as you're doing something correct, I'm not a real stickler about it, but what I'm actually going to do here is to get rid of this divide by 3 is I'm going to multiply both sides by 3, because this is 2x divided by 3. When you see a fraction bar, that is an indication of division. So by multiplying both sides by 3, I'm getting rid of that denominator because it's canceling out. It's like 3 times 1 over 3 is 1. It cancels out. So bring down the 2x. 14 times 3 is 42. We're going to divide both sides by 2. And x equals 21. When you plug in 21, 2 times 21, 42. 42 divided by 3 is 14. 14 divided minus 4 is 10. It works out. We know that we've got the right answer by checking our answer. This is a step that's often skipped by students, but it can ensure that you always get the right answer if you always check your answer. So that's it for today. We've had several examples. This is the type of algebra that you're going to see throughout the course, the whole course. So we're going to have some practice questions. Make sure that you stop me in class and ask any questions that you've got. Have a great day, and I'll see you in school.